That's fine. You keep. This guy really likes the recording job. Okay. Okay, let's try to um screen share again. So we've already established how nodes are reference types. And if you create one node, and it's going to be very important when you come across some of these node-based data, like linked list questions and trees questions, where sometimes you think you're creating a copy of a linked list by simple assignment. Then you realize, not really. I'm actually not doing that. Okay, sorry, but the screen mirroring is actually not working. So we're going to have to use the coding space for today, which is fine because I think people can still focus. Okay, let's go back to the coding space. It's not connecting, unfortunately. I think it's because I'm not using private Wi-Fi, but it's fine. Okay, let's go back to the coding thing. I mean, people are able to see, right, when I write the code there. So let's use that. Okay. Can you want to see where we are now? Can everybody see?
Yes.
Okay, so now we already discussed arrays, right? How arrays are really cool. And we had this I want to just show you something. I want to show you something very quickly. Give me a second. I want to show you something very dear to our hearts. Okay. Okay, so you remember this, right? And then we said we can assume the computer memory is a grid like this. Do you remember? The memory is like a grid like this. I hope you all remember. And we said that if you are storing something, right? If you're storing something in there, like using a list, what it does is that it stores it contiguously, right? Like A, then like B, like C. So if I create a list and my list is like, I have a list like L is equal to, A, B, C, or if I create an array and it's like A, B, C, this is what happens. It goes to the computer storage, then finds a contiguous block and puts the ABC in. Do you all remember that? Does everybody remember?
Yes.
Okay. And some people raise questions. They're like, well, what if we don't have the contiguous space available? What if all these things, is this a best thing? Given the restriction, we're like, there's dynamic resizing and all these things. But linked list also gives us another way to go about this thing, right? Where we don't fix ourselves to this restriction that we need everything to be contiguous. And that's when linked list comes in. Linked list allows us to still store data in our memory without binding them that it should be contiguous. No. So if this is my whole memory, linked list allows me to put A here, I'll put B here, and I'll put C here. That's what linked list allows you to do. That is the power of linked list. They allow you to scatter your data in your memory across different areas. Let me enlarge this, right? So you can put this guy here, you can put this guy here, you can put this guy there too, right? You can put D here or any data that comes. So that is number one. Then number two, you're like, well, if my data is scattered in memory, how then can I access them? With array, I knew that they're contiguous, right? So I can simply, just look through it. I can simply just do index and I can do L, I can just be like, array can be like, give me L index, L index is 0 plus 2. And it's just give it to you. But linked list now, we say that they're all scattered. So how then do I get the information? And the power comes in the fact that they are also the nodes. So these are nodes, they are reference types. With reference types, we have the access, we have access to the address, we have the address of the reference of the node, right? Which means that in computers, if you have the address, you can find them, right? It's not like Ghana where we don't use addresses, right? If I know B lives in Damango, I can easily locate Damango. If I know D lives in Tanzania, I can simply go to Tanzania and pick it up, right? So that is how we do that. But they are scattered in memory, but using their addresses or their references, we can still access them. Does that make sense? That's what linked lists are. Does this overview of linked lists make sense to everyone?
Yeah.
Yeah. Yeah.
Okay. So now let's come to, we said these are what we call nodes, and I've defined what a node is here for you as we started. So we said this is what the definition of a node looks like. We just call it node. Computer science we just have terminologies for things just to make it standardized and people can communicate it. You can call it anything you want, but we call it nodes. Now, every node has properties, right? The first property we have is the actual data you want to keep, the data you care about. Here, the data we care about is what we call val or what we call value, right? That's the data we care about. So if I take this, the data I care about is, let's say, A. The data I care about is, let's say, B. That actual data I want to store. Does that make sense to everyone? So our node has the data we actually care about. We call it here, we're going to call it val. So it's a property of the node. We call it self.val, right? You can call it self.data or anything you want. Yeah, we're just going to call it val. Then the next one also is that it's a linked list. It's a list. You still want to be able to access B from A. You want to access B, you want to access D, you want to access C. And we told you that the way you do that is by using links, by using pointers, right? So we need a way to connect A to B. So what we do is that we use what we call a pointer. So you're going to call that one self.next, self.next. So self.next is like if I'm on A, this self.next is going to point to the next node, right? Going to point to the next node. Let's put that one in mind. So let's give an example here. So we initialize it to none because the default value of objects is none. What is the default value of strings? We mentioned it. What is the default value of strings? Anyone? Put in the chat. Default value of strings. Is it Cornelius? Is it the empty string? Default value of strings. Is the empty string correct? What's the default value for integers? Is 0. What about Boolean?
0.
Oh, Boolean. It's false. Good, good. And for objects, it is none. N-O-N-E, right? It's none like this. Okay, so that is that for that. So that's why we're like, well, something is going to point to a certain pointer. It's going to point, it's an address, it's a reference, and the default for that is none. It can currently do languages like C, it's missing things like null pointer and all these things. Okay, good. So let's come here. So if I create the first node, let's call it node A, right? Node A, we create it like this node, let's call it A here, uppercase A, right? And then I also create my node B like this, and I'll be like node, B, right? I've created these two, right? But now, so when I do this, node A and node B, what Python has simply done is that, look, it has just gone to the memory and it has created node A, like, it's put node A somewhere in memory. It doesn't care. It's like, man, node A is node A. I want to give it some background color. I don't know. I should have done something more colorful. I'm so sorry. Let's give it some background color. Yeah, it puts node A here, then it chooses node B. It puts node B here, right? It just puts them somewhere randomly in memory, right? So that's what it has done right now. If you visualize it, you see that if I visualize, like forward, so you see node A is at memory address, so it creates node A. Node A is at, let's return it. Node A is at memory address 3, right? It's like, okay, I'm done. Then you go to node B. It also creates node B. It's done. Then node B2 is at memory address 4, right? Like this tool uses consecutive numbers to make it easy to track, right? But like it puts at different places in memory, right? So there's no relationship between them. So now if I want to create a linked list, a chain with them, now I have to create that reference, right? I have to now connect A to B, right? So that's what we do here. So when we do, so to do that, I say node A dot next is equal to node B. So now when I do this, right, let's visualize it now. If I visualize after line 9, right, you can see now that this is node A. Can you see node A is somewhere in memory? There's this node instance, right? So there's a value is A, but its next is now the address of B. So can you see the list, the chain is being created, right? Like this is node A. Now its next points me to this, and so on and so forth. That's how basically what linked lists are. You create nodes in memory, and then they just use links to connect to them. Does that make sense to everyone? What linked lists are?
Yes.
Okay, good stuff. You need to be able to, implement linked lists from scratch. Python, when we did, queues and decks and all those things, we saw Python giving it to you free of charge, leaving arrays or lists. Python just gives you this. Linked lists, Python doesn't give it to you. Well, not that I know of, but you should be able to create your own linked list, like create your own node, then, connect them. So if you have node C, but you have to create the node first before you connect. People have another way of doing it like this. They want to create a linked list starting from node A. This is some code people write, because let's assume you never use the variable node B, right? So it can just be like, let me show you. Like I'll just be like, my linked list is going to be, look at this code I'm going to write. Node A. I used the first one it was when I started programming, it was just too bulky for me, but now I used to write Can you see the code I'm writing? Please take your time and analyze the code. After that, I'll ask you. Actually, sorry, I don't want to do this. Oh, this one's right. Okay, next. I usually call this NXT. Please, I'm not writing any scary code. Don't worry. Be at peace. Be at peace. Be at peace. Be at peace. 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 Okay. Can we see? Can we all see this linked list? Can we all see it? It's a linked list. Can we see what I just did? Please take your time. Look at the code. I'm not going to talk now. Take your time. Look at the code. I've created a linked list right now, but take your time. Look at the code. All I need to do that is this. Let me just make it like this for you. I don't know if this makes it better, but sure. Okay. Does this make sense to people? What I just did? Does this make sense to people?
Yeah.
Right. I just created the same linked list, right? It's the same linked list I created, right? Can somebody tell me what the linked list looks like in chat? what a list looks like. Is it like A maps to this, like, you can just be like, it's A to, just be like A, B, C. Exactly, right? As John says, that's what it looks like. And this is fine because, look, when I do this, if you visualize, right, Python is going to create all of them. We're going to create all the various nodes. Look, it's going to create, like, look, let's come here. Look, it's creating all of them. After I'll show you. It's creating all of them. It will create all of them for you. Like, it creates all of them for you. Like, if you look here, let me show you here. See, how can you see that's created all of them here? So like it has created, so this address 8 at address 7 at address 8, address blah blah blah, right? So because maybe I don't want to assign these to variables, right? Or anything. So you can actually, you don't need to assign to variables. Like you don't have to create node C and then do the list. No, you can actually do all of them in a line because this, like, node A, its next value should also be a certain node. Its next should also be a certain node, and on and on you go. Make sense to everyone? Does that make sense to everyone? Yeah.
Yes.
Yeah, so that's basically how that also works. And it's amazing, honestly. Just play around with it, and please learn how to create your own linked list. It happens usually in coding interviews. I've come across interviews, and I the interview, I was telling them, like, should I create my own node? It's like, oh, some interviews, some of them are like, sure, you can go ahead. Some of them be like, oh no, you can assume. So even if they tell you assume, what I usually do is that I still write. I'm like, oh, okay, sure, I can assume. Okay, so I'm just going to say I have a node, and the node has these properties. It has, let's say, I just make it the string, to make sure you're on the same page, right? I'll be like it has a node and it values are val and next, or something. Just, you don't have to write, because sometimes it takes time, right? Define this, because maybe you could have forgotten how to do def init, right? But in an interview, the main thing is like, oh, you don't have to. So just be like, okay, so I'm going to assume it has two like fields, val and next. Does that make sense to everyone? And then you go on to do your code. That is number one. Can we move on to linked list? Sorry, we're already here. Okay, so that's all for that. Now let's go to common algorithms on linked list. I've been begging people since most of you were born. But like, I've been saying something that as you learn these things, you come across algorithms which should be very fundamental to you. For example, if I tell you to find, two sum, or find, these things, they should be very fun. If I wake you up from sleep right now and I tell you to answer that and let me get a Mercedes Brabus, you should be able to do it. And linked list is the same thing. There's some algorithms that are so fundamental. Like you have to know them. Like you have to know these algorithms, like they should be like second nature to you. You have to know them more than you even know your middle name. Like you have to know them so much. And these are the algorithms: reverse linked list cycle, find middle node. It's probably not here, but find middle node, and remove nth node. Those four algorithms, you must always know them. You must know them for linked list, because most of the algorithms you saw with linked list are just these four algorithms combined. Like, trust me, it's just those things combined, right? So you have to know them. In other words, you have to know all those questions all the solutions to the questions here, because you come across so many questions and it's just those ones. Trust me, it is just those ones you're solving. Like remove nth node from a list. It teaches you the technique of, we have to do those techniques actually. We're going to discuss fast and slow pointers and two pointers, and making copies. We did this yesterday in coding room. I really wish people were there though, because we really went through this. If you check our chat, we really explained this thing so easily, and it makes sense to everyone. I don't know if people have tried that. Have everybody here tried that question? It may look intimidating and difficult, but actually it's not. Once you understand the algorithm. I decided to record it, but we couldn't. Sorry, I just want to show you. But wait, has everybody tried that question? Copy node with random pointer. People haven't tried it. It's one of my favorite questions that I was telling the people yesterday, because you do the same thing for graphs too. Graphs have a similar version. Where is it? Yeah, this was what we did. If people have done that question, I can't explain it now because people want to know what is happening. But it's a very simple algorithm. It's so simple. But then let's take what we are. Let's take the ones we want to do. Let's do reverse. Let's do find middle node. Anything. Which one? Somebody choose. Somebody choose a linked list algorithm. Let's take a look at. Choose. Middle node. Okay, because middle node is not here. Okay, middle node. Let's look at middle node. Okay. Let's look at middle node first. So middle node. Let's take our linked list. So please, the linked list algorithms, you have to know them by heart. Linked list is so important, by the way. There are many applications of linked lists too. I try to add applications to the data structure. So linked lists are so important in real world. I came. Somebody sent this post. It was like, we should look at this and about how leet code DSA things are like. I'm like, it is not right. Like, I build database. I work on a database team. We build database systems. Like, we use linked lists. I've written functions which are recursive. I've actually written recursive functions in my code base, right? I don't know if I can show it to you people sometime in the future, but actually, don't worry. Me, I'm going to show you. But I'm trying to say that the things you learn, the coding things you're learning here, they're not useless, right? Like it's good for you to know them, know those fundamental things because they can come in handy, like super duper handy. Let's see if I can create collation away hash map. That's not the name. What's not even how I named it. Okay. I'll probably name it. I'll probably call it hash table. Okay. Sorry, give me a second. We're almost there. Hash utils. It's in hash utils.c. Today is today. It's oh, I have to. I have to sign in. Sorry, give me a second. I want to show you something. I want to show you that the things actually right now not. Look at this. Okay. What's happening here? Sorry, give me just 1 second. Okay, let's go to, I think it should be in PG documents DB, and then it should be in the source. It should be
Yeah, sometimes I think the indexing is slow on GitHub.
Yeah. Utils, then we should have a hash utils. But utils, is it in call? Okay, hash. Oh, it's hash set utils, not hash utils. Okay, so if you look at this function I wrote, create piece. So this we're creating a hash set. I don't know if you remember, the question to create your own hash set we did right sometime.
Yeah.
To get it together, right? So you're basically creating my own hash set. Let me get to the one I wrote. So that was create based on what it has a collation. So you're creating a hash set, right? And then here what we do is that we specify the size of the key. So say think hash table. Let's say hash table, right? Hash table has key value pairs, right? So here I'm like this information to create my hash table. I'm going to have a size for the key, then a size for the value. Then when I'm looking for two things, I have to compare. So realize that you jump into a bucket with the hash, the hash table hash set. Then you're comparing. Are you this? Are you this? Do you remember? Like once you even get to the bucket, you still have to compare. Like after you do the hashing, you get a bucket, right? Then you have to now go through the buckets. Do you remember and compare? Are you A? Are you B? Are you this? Right? You have to. And somebody was like, "Isn't this searching linear time?" We're like, it's linear, but like we also don't do it for every entry. I don't know if you remember, like from last week, right? So yeah, so this is that function to do the comparison, right? And this is the function to hash the value. So remember we said, oh, hashing, you can take the mod of the length. Do you remember? We're like, that's one way to hash it, right? To hash the value to determine its bucket. So now I have to write my own hash function, right? Look at the hash function I wrote. Okay, this is the hash function I wrote. So I'm like, okay, let's go to the call. Usually we use a call function. Call function, where are you? Okay, call. Then I wrote this call function. So if you look at, how do I put this call guy? Oh, I just want the call function. I want to show you. People be like, you never use recursion, you never do these things. Please, you actually do. These were just building HTML, CSS sometimes, so they don't know. So if you look, we do recursion, like, in case, you can see my base case here. You can see my base case here. You can see a recursive case here. You can see another base case here. I called it number 2. You can see a recursive case here. I want to look with a recursive case. Right? You can see I'm calling the function itself again, right? With some hash function call. So these things we're learning, please don't think it's like just using everything. Yeah, let's go to solving questions and everything, but like you learn programming, you learn some of these things. Some of you probably would never even think of creating own hash sets before. But it comes to real world and you're like, oh, this thing exists, right? So don't trivialize it. It's a real world thing actually doing, right? Okay, let's come up to it. So linked lists are used in database systems for sure. And because database systems, some you do we call pages and all these things. Trees and to trees, you see trees, binary trees also used. We have something called B plus trees. That's how many indexes in database systems are, like Postgres B plus trees, even Gene indexing and all those things. We also use linked lists also in certain indexes. We call it posting tree, actually used posting list indexes, right? And if you look at the image, so they're used, right? They are used in places that, as you can see, it's like it's you. So these data structures you're learning are not like useless things. Please church them. You can go to the interview, like, oh, what do you use linked lists for? You can be like, oh, some database systems use linked lists, some indexes also use linked lists, and so on and so forth, right? So those are things you should also be looking at when you're learning these things. Okay, so now let's look at the question we wanted to look at, to find a middle node. So look at something here. So if you get a question like, go to an interview that asks you to find the middle node of a linked list, right? There are a couple of questions you can ask, but I'm going to just focus on one question. If I have a linked list like this, I like to put my node in like square bracket like this. So you have like 1, 2. So let's assume we're doing a question now. 3, 4, right? Then it points to none, right? So, and then we have another one, which is like this. Then put this one here, 5. And ask you, what is the middle node here? For the first one, put answer in chat. For the first one, what's the answer here? For the first one, put answer in chat. First one. First one, what's the answer? What's the middle node? What's the middle node? Anyone? 3. It's so clear, right? It's super duper clear, right? Yeah, it's 3. Now, the second one, what's the middle node? The second one's the middle node. Okay, someone saying 2 or 3. The rest of you, what's the middle node? It's 3, right? So realize that if it's an odd length list, the answer is clear. It stands out to you as 3. But then you ask the interviewer. So the interviewer may come being like, oh, if it's an even length list, and you can see the only difference is the parity. This is even, this is odd, right? Maybe the interviewer came thinking it should be 3. But you wrote your code and it is 2. So the test are failing, right? Or maybe he came with 2 and 3. So these are the things you clarify in an interview, right? Find a middle node. But like middle, if it's odd, it's clear. It's a middle one, right? Be like, blah, blah, blah. But it's even, it becomes clear. So these are the questions you ask in an interview, right? So for now, which one should we do it? Should we do, so when it's even, they're going to be 2. Do we do the first or the second one? Somebody choose. Should it be the first or the second one? The first one. Okay. Someone also say be like the second one, right? I don't know. We're just going to write some code. Whichever one the code works for, we pick it like that. But I'll show you how to twist it to the other one. Okay. So to do the node, let me have a couple of techniques we usually talk about, right? And you've seen these techniques to solve the coding problems. See, we have so short time here. I can't teach everything. That's why I tell you to go through these resources. So we're going to use one of those pointers called 2 pointers, right? This is how 2 pointers work in linked list. What we do is that we have 1 pointer. I usually call it, what do I call it? I call it fast and slow, but technically it's not fast and slow. But I'm just call it pointer 1 and pointer 2. Let's say P1 and P2, right? P1 and P2. So what we do is that, let's just call it fast and slow. It's not fast and slow, but I'm just going to call it fast and slow. Or should I call it first and second? Let's call it first and second, right? First and second. So what usually happens is that the first pointer usually is ahead. The first pointer usually is like ahead of it. So like, let's just do fast. I feel like fast and slow makes sense. But no, yeah, this is not the tortoise and hare. That's why I don't bring the confusion. Tortoise and hare is different, right? Let's get better name for the pointers. Let's use pointer 1 and pointer 2. Pointer 1 and pointer 2. Pointer 1 and pointer 2, right? Or we can do L and R. Let's do L and R, left and right. Left and right is fine. So the first technique we're doing 2 pointers on linked list. Let me just write it here. 2 pointers. It would be better if I were writing. Things would be more seamless, but it's fine. So what happens is that the R pointer will always be ahead. The right guy will always be ahead. He will always be ahead of the left guy, right? So for linked list, usually, this is a technique which we usually do. We initialize both. So here, somebody didn't ask that we say the linked list is scattered in a memory like this. So how do we even get ahead? How do we even get access to links on its own? Usually for linked list, you have access to the head pointer, the first node. So if you're using the first node, you can jump to the rest, right? So we generally have access to the first one, which is we usually call it head, the head of the list, right? Okay, so usually when we initialize both of the pointers on the head. Can we all see them both on the head? L and R are both on the head. Can everybody see it? L and R on the head. Can we all see it here? Can everybody see here?
Yeah.
Then what we do is that we make, R take 2 steps. R always takes 2 steps. So if this R takes 2 steps, right, they're both on the head, Olu. So R comes to 2, then it moves to 3. That's taking 2 steps on every iteration. Then this L guy takes 1 step. Can you see where we are now? Can everybody see it? This is a fundamental linked list algorithm you use for so many questions, so please understand it. I'm showing you the 2-pointer algorithm for many linked list questions. Then, so we are done with 1 iteration. So the first loop iteration, right pointer takes 2 steps, left pointer takes 1 step. Let's do it again. Right always takes 2 steps, right? This guy takes 1 step. Can you see we have touched the whole linked list? We've touched everything. And now where is the left pointer standing? It's standing on the middle node, which is the 3 he said. Can we all see we found the middle node? Can everybody see it?
Yeah.
Yes.
Okay. So now whenever I show you an algorithm like this, there should be a question. The question is, when does this loop end? That's the question you should always ask for. Because I'm like, take a step, and I'm like, oh, can we see it here? Hooray, we are done. That shouldn't be the end. You're like, wait, when does this R end? Can somebody tell me when does this R end? When did I stop the iteration? When did I say we're done? Why did I say we're done?
When it hits none.
Yeah.
When
did it hit none?
no,
It's a
when
question.
its next is none.
It's the last one.
Okay, exactly when r dot next is none. One thing I realized when I was learning English many years ago, like 85 give or take, is that it's sometimes very tricky when to end it. You are like, should I end it when r is pointing to an actual node? Please listen to this part carefully. It's so important. You're like some algorithms, you see that r is actually pointing on an actual node. Sometimes it's pointing on none. That's the problem I want us to solve right now. Sometimes it's pointing on a node. Sometimes it's pointing on none. Because of this problem, that is why I'm like, if you're doing an interview, don't just jump to code. If you had showed the interviewer this thing, you'd have noticed that, oh, it actually points to the actual node, right? But if we just jump into code, you probably will be confused. Now, whenever your algorithm ends, when r points to the actual node, your condition becomes r dot next. So what I mean is that the code becomes, the following becomes while r dot next, then do whatever you want to do. Then take the steps. So while r dot next, r is equal to, r always takes 2 steps. Do you remember? R takes 2 steps, right? R is equal to r dot next, take 1 step and take another step, right? But then L takes just 1 step, right? Then just continue. At the end, when this loop ends, we'll be on the middle node. And then we are done. That's basically the whole code to find the middle node. That's the whole code, right? Well, r dot next. Now, let's explain what this r dot next means. The 2 reasons I'm going to give you why this case is why this is the same. To say well, r dot next simply means that, none is not a truthy or a falsy value. We've explained this before. It's not a truthy or a falsy value. It's not truthy or falsy. It's falsy, right? None is false, right? Good. So that means that this is the same as saying while r dot next is not equal to none. By say we write good code here, you can just do while r dot next. But this simply means that what is not equal to none, right? That is one case here. So, and as you can see it, we only continue the case, like we didn't move r to none, right? We didn't. So can we understand the first part of the argument? That we're like, well, r is not none, right? So here, so that means that after, when the loop ends and it goes here, r is none, it will not continue, right? It will just not continue, right? It will not continue. Then this is also the second case. Now look inside the body of the while loop. Look at the body of the while loop. Can you see the body of the while loop? We're doing r dot next dot next. Can you see we're taking 2 steps? Can everybody see 2 steps? Can everybody see it?
Yeah, 2 steps.
Now, if you're taking these 2 steps, if you first do r dot next and it hits at none, what would be none dot next? What would be none dot next? It would be error because none is not a node. Does that make sense to everyone? So if you're going to write a linked list algorithm and you're going to make some pointer take 2 steps, please always make sure that r dot next is not equal to none. Does that make sense to everyone?
Yes.
Yes.
These are the 2 things I want you to keep in mind. That number 1, ask yourself, when does this algorithm end? And if you simulate it like this, it becomes clear to you. If it ends when, if it ends at a time like this, right, you only cared about when it's on an actual node, then your condition is r dot next, right? And again, if you're going to use r dot next dot next, then always make sure that r dot next is not equal to none. Because if r dot next is equal to none, this will throw an error because it gets none dot next and that gives you error. Does that make sense to everyone?
Yes.
Yes.
I think it's so important. You probably won't know about when you do a lot of questions, you realize something like, when should I end the loop? When should I run into errors and realize this was the situation? The r dot next was none or something like that. Let's go to the next case. So this is odd length list. Next one, I'm going to consider the even length list. Let's do the same simulation here. Yeah, go on. Ask your question, please.
Okay. Yeah, so I was thinking of a case where let's say r is on 4, but then since we are and then maybe we do dot next. But then I was also like, okay, since we are moving by 2, maybe that would
then come to none.
Because I'm thinking,
right? It'll come to none. But look, so this is what he's saying. Let's assume we have both of them here, right? So then the loop comes, right? The loop will be like, well, r is not equal to none. This is true, right? Take r 2 steps, take l 1 step. Can we all see it here? So r takes 2 steps, right? L takes 1 step, right? So now the for loop will come again. Will the for loop continue? Will the for loop continue? No. And you've ended and it's done. You're fine. You're basically good, right? You're basically good. This condition means that if you come and r, I'll actually show you the next case. Actually, there's another case. It's supposed to be r end, right? But I want to show you that's one with the even length one, right? So before, okay, let me just mention it now. It's everybody following us. Let me just mention it now. Before you do just r dot next like this, you have to first check while r and r dot next. This is the reason. If r is none, right? If you just have r to be none, right? And do none dot next, we all agree this will give you an error, correct? Do we all agree?
Correct.
Okay. So we first do what r and that means that if r is not none, right? And r dot next is not equal to none. That is the condition. So what we're basically saying is that if you know it's going to condition on r dot next, please first check that r is not none first. Because if r is none, this will lead to an error. Does that make sense to everyone? You sure you want to do the even length one? Should we do the even length one?
Yeah.
But does this make sense too? The fact that if you're going to do a .NET .next, first make sure, and it's the same thing, right? You're going to do a .NET .next, make sure that .next is not none. You're going to do a .next, make sure that R is not none. Like it's kind of like a similar thing, right? Like, hey, if you're going to do .NET .next is not none, make sure .next is not none. Go to .next, make sure that R is not none. I hope that makes sense to everyone. Because also to throw an error, it's just locking in an error, right? Okay, let's look at the even length one. Let's do the same thing. R takes 2 steps, right? R takes 2 steps. L takes 1 step. R takes 2 steps. And you see now the R has come to the none, right? And then L takes 1 step. So now which one do we get as the middle number? Can you see is the second of them, the second of that tie you have. Can everybody see it here?
Yes.
Which means that if you use this algorithm to find a middle node, whenever there's something like this, it's going to give you the second node as the middle one. Does that make sense? This is what you have to clarify with the interviewer. Does this make sense to everyone, please? Does this make sense? Does this make sense?
Yeah. Yes.
Okay. Now, somebody says, well, like, we should try the first node, right? The first node. And to try the first node, linked lists are so beautiful. We use the concept of what we call a dummy node. This dummy node will solve a lot of linked list like problems. When you are like a lot of them, you use the concept of dummy node. Dummy node simply means this. You have your linked list, it's fine, but you want to, there actually, might explain the 2 cases you use a dummy node. One case you use a dummy node is this. If you're going to make a change, please listen to me carefully here. You're going to make a change to your linked list, right? And that change can affect the head. You use a dummy node, create your own head. For instance, you're going to remove a node from the linked list, right? And you think you may remove the head. In that case, use a dummy node and create a certain temporary head, right? The reason why we do that is because you know that in the linked list, we only have access to the head. Do you remember? We only have access to the head, right?
Yeah.
So if you go and disconnect and remove the head, now, like, you're lost. You can't find the linked list anymore, right? You're lost. But let's assume, right? Follow me carefully. But let's assume you created a dummy node. Let's say node 0. And you put that 0 here, right? After you remove that original head, which is 1, right? Remove it like this. You can still use node 0 to access the rest of the chain, the rest of the list. Does that make sense to everyone?
Yes, sir.
Please, is it getting a lot? The rest of you, does it make sense?
Yes.
Dummy node, right? That's what one reason when I use a dummy node. Like, okay, I'm going to remove a node from my linked list, but I may end up removing the head. Well, if I remove the head, then like everything is lost. I've disconnected the head, and the head is the only thing I have access to. Therefore, I'm going to add a dummy node such that my dummy node always connects to the head, right? The head node. So even if I remove that one, that's kind of like the new head. So I remove this guy, I still have to remove this guy like this, and this next pointer, I can still use this guy to connect to the rest of the linked list. Actually, I got to this.
Quick question.
Yeah, go on.
So when you do that, is the dummy node going to be like the head, or like you're not going to call it the head or something? Like, you get my question?
No, so what I do is that I call it, just create a dummy is equal to like node. I just give it the value of 0. Not just like dummy dot next is equal to head, right? So when you get the question, right, the question is like def some function like solve, then it passes the head to you, right? So when I get this, I'm just like I'll create my own dummy node 0. Then I just do dummy dot next is equal to head. So now when I do this, I've basically linked it, right? I've done the linking here, right? I've done this linking. Does it make sense? So this was the linked list when it came in, right? You only have access to the head, this head, right? Then using the head, you access the rest, right? Then you're like, let me add the dummy node. And you just do this. You create the node first, as I do on line 3, right? And then I connect it dot next to be the head. And I just do this. Does that make sense to everyone? Please, does this make sense?
Yes.
Good. So that's what happens. So I've told you, and that the other condition is probably I come to now right now. So now, node our linked list is 1, 2, 3, 4. But we've added a new dummy node, right? So let's start our algorithm again. I'm spending time on this middle node thing because I said it's a fundamental algorithm you must know, right? Okay, so now let's move right twice. 1, 2. Let's move left 1. Let's move right twice. 1, 2. Right? Let's move left 1. Right? This condition is kept. We still maintain this condition, right? While R, right? There's R is true. Can you see R is true? R is true, right? Because R is a node. But R dot next is false. So would the loop iterate again? Would the loop?
No.
Everybody, please look at this carefully. Would the loop go again? This is my current state. Will the loop go again? Will we execute this loop again?
No.
No.
I hope everybody's convinced we will not go again, right? Because R is indeed a node pointing to node 4, but R dot next is not, right? R dot next is none, right? Therefore, we will not go. And can you see your middle node is now 2, the 2 you wanted? And you were able to get to the 2 simply because you added a certain dummy node, a certain temporary node, and I has given you your answer. Does that make sense? So if you go to Native tells you, so those of you who are like, this is the first node, can you see that's a bit more complicated? Don't have to insert your own dummy node, right? But if it's like the second one, then it's straightforward. You don't have to insert any dummy node. Again, dummy node is important. It's many. Let me show you some of the solutions to these questions, which I did. Reverse linked list is an algorithm you must know. Honestly, let me show you how many times I've written this code. I go to a point I could just recite this as a song. Can you see? I done this question like I said in 2021 in January, 4 years ago, which is like 40 in some worlds, parallel universe. But like I've done in 2022, 2022, 2023. It's like almost every recruiting, that's like almost every recruiting cycle. I did this question, right? Like it must be second nature. Oh, this was me flexing my C++ models. Let's look at Python. Let's look at this. And if you look, you see I use the same names. I told you the same before. You're writing solving question, everything. Like get used to some conventional using variable names. Like me, I don't think I'm writing the code like this anymore. I'm going to be like current, previous, and next. I've explained this algorithm a couple of years ago. Coding room got Lynch more. Take a look at it again, like how it's moving. I was coming to say something. Sometime I think 2023 or 2022, I was almost always praying I get a linked list question. And I have also another friend, Jeff, I use Google now, who was also praying he always gets linked list questions. Linked list questions are such that it's like once you're able to, like those people have been solving the questions, like once you're able to know the algorithm, it's a bit easy to implement, right? You're like remove node. You're like, okay, to remove this node 3, I just have to get here and then disconnect it, right? It's like a very mechanical. Linked lists are very mechanical, right? Like you have to create a certain, it's tedious, greedy algorithm. No. Once it becomes writing the code is the easiest part. So I want you to get to that space where you really want those questions. So this is a very straightforward question. It's just like take this pointer. If I tell you to reverse this linked list, right? Like it's not scary. I might reverse this linked list. You're like, okay, I'll just take this pointer and flip it back. But how will I do that? It's why you have to go and solve the practice questions. Let's look at the other solution. So I said this an algorithm you must know. Reverse linked list. The algorithm is cycle. This is a tortoise and hare algorithm. Flight algorithm. And you must know it. It's a must know.
Linus, I have a question.
Yeah, go for it.
Yeah, so with respect to the middle node we were finding earlier, for the second question, if you're supposed to find the middle node and then your output is supposed to be 2, can you just move the right pointer like to the next item before you start the iteration?
Well, the right pointer to the next one, like here?
Yeah. Yeah, so yeah, for example, so you just move the right pointer to the 2 before like you start the iteration.
No, you actually can't, right? Because here, oh, wait, you mean like right from the start?
Yeah, right from the start.
Well, I mean, like the algorithm is like you would take 2 steps, me, I'll take 1 step, right? Like, why do you want to go before me? Right? The algorithm is like and at the start of the algorithm, you can be like R is equal to head dot next and leave this guy at head. I mean, you could, right? But that complicates your code, right? That's like your code becomes at the start, you're like head dot next, then like L is equal to head, then now you create your dummy, right? And then you link it. Like you've already made them take steps forward, right? But I feel like this code gets complicated, right? It's like basically repeating this is what I mean, right? It's equal to head, right? But instead, you could have just written this line. Once you write this line, you can just write, instead of this, you just write left is equal to right is equal to head, right? Oh, sorry, dummy. Like, first create a dummy node, link the dummy node, make them start at the dummy, right? Like just make them start at the same spots, right? Instead of moving them first. I feel like it makes the code easy to follow, right? Does that make sense?
Yeah.
I have to work, but I just think this makes it easy to follow, right? Okay. Linear cycle is that question you must know. This is the first, and it's amazing. It's the same question we use for duplicate numbers. I don't know if people have solved duplicate numbers, but it's the same algorithm we use. So this one, so you can see that this algorithm we just did, actually, it's the same one. This we just did the fast and slow. I am so sorry. This is still the same fast and slow pointers. It's actually the same thing. So fast is the same thing. It's a fast and slow pointer. What was I thinking? This algorithm just is the fast and slow pointers. That is right is running very fast, right? It takes 2 always, right? And this guy takes 1. This is why we call the fast and slow pointer. Aha, so you can see, this same fast and slow pointer algorithm we just looked at is the same algorithm that solves linked list cycle. It's the same thing. Can you all see it here? While fast and fast dot next. Slow is equal to s dot next, f is equal to f dot next dot next. It's the same algorithm. So it solves this one, it solves middle node, it solves a lot of things. So it's a fundamental algorithm you should know. Sorry, the person who put in the chat, I am so sorry. Yeah, it's indeed Floyd's algorithm. And what's wrong with me? If you come to merge 2 sorted lists, it's so mechanical. You don't even think. Here in linked list questions, you really thank God. Like you don't think merge 2 sorted lists. It's probably like, look, you don't think. Look at the solution. It's like you don't even need. Let's see C++ as a challenge, right? Even though you don't know the language, but look, you realize it's not the scariest. Am I sure? Yeah, this is just like if the first one is none. If I'm making 2 lists and the first one is none, just give me the second one. If the second one is none, just give me the first one. Then everything like that is oh, this is recursion. I'm so sorry. I don't show the recursive approach. We came for Python, right? This was that's when I was flexing my muscles. Like, see, after you get to do the thing well, this was look when I started 2022. Look at the ugly code I've written here. Let me show you the next thing. Let me show you the next thing in programming. The next cool thing. Is everybody following? But people solve this question. I'm talking because I'm assuming people have done these questions though. I beg. Let me show you something. Okay, I will look at this code. Can we all see this code? Can we all see this code? If you're not done this question, yeah. Can we all see this code?
Yeah.
Let me show you even a lengthier one. I want to show you something in program. Please don't leave the call. We are almost there. We are almost there. Let's look at this code. Look at this code. Everybody, take your time. I really hope people have solved this question. I don't know, but like, to make what I'm coming to do so much easier. Like, you will see this code, right? So I'm merging 2 sorted lists, right? So list 1 and list 2, right? Then, but I take the minimum first because I want the results to also be sorted, right? So like 1 and 1, I'm like, they're the same. I can pick any of you. Then I move on. I'm like, okay, I'll put this one. Then, the algorithm makes sense, right? Like, and it's like, I don't have to show this because people are supposed to have solved this question already. But like, okay, let me just show it for some people's sake. Right. This is just a question, right? And it's like you have like 1, 2, 4. You have like 1, 3, 4, right? Like this, right? They want to merge them, right? But they should still be sorted. So like you have P1 here, pointer 1 here. Let's call it P and Q. P here, and you have Q here. Q. My math teacher was okay. P and Q are like P and Q trying to smaller. 1, they're the same thing, right? They're like, okay, I'll take the P1, right? Can you see what I'm doing here? So once you take this guy, look at this. Look, it's just like in all lists that you merge sorted. It's the same algorithm, to be honest. Then you move the P guy forward. 2 sum. The question we did 3 sum. It was the same things, right? If you choose the minimum guy, like always, the minimum guy suffers. He moves on forward, right? Then you compare 1 and 2. It's the same algorithm. So I'm like, do the practice questions. You see the pattern. 1 and 2, you're like 1 is smaller. Okay, so then I'll choose kills 1. All right. Then I'll link them again. I'm going to show you something. Then Q, it's like P and Q, you're like, 2 is smaller. So I'll move P. I'll choose P's 1. Then, it'll be like, 2. Can we all see the algorithm basically, right? So you have the algorithm. Now let's come to the code. So if you see the code, today be today. So look at something. Have you all seen what I'm seeing here? Have you all seen what I'm seeing here? Has everybody seen this?
Yes.
Yes.
2 things I want to show you in this code. Thing number 1. Thing number 1. Let's assume that from the start, right, you were able to deduce that. Let's say the code is like this. Follow me carefully. It's very important. Def merge. Let's say we call them list 1. and list 2, right? And at the start, look at something. I beg, look at something. At the start, you were like, oh, list 1 is minimum, right? List 1 is minimum. So you'll be returning list 1, right? But then you have a while loop. Look at this. Please follow me. You have a while loop that says while list 1 and list 2. And then, you're doing all your algorithm here, right? And at the end, you're like, return list 1. Look at something. As you are doing inside the while loop, list 1 is equal to list 1 dot next. What is happening is that after this while loop has ended, list 1 will not be pointing to the head of the linked list. Do you know what I'm trying to say? Like when you do list 1 is equal to, I'm just showing things which make people wrong in linked list questions. Let me show you something here. Let me show you something here. Can you see this? Can everybody see this head pointer here? This head pointer here. Can we all see? I'm doing the hash cycle.
Yeah.
Can we all see this head pointer here? Or we can do the middle node question if people are more comfortable with that. Look at this middle node question. Can we all see this middle node question here? Everybody can see it, right? Now, if I did left is equal to, if I did right is equal to dummy, right? Right is equal to dummy. Let's even make it simpler. Let's just do the odd case one. The first one we did. Left is equal to right is equal to head, right? That's what we have, right? And I'll be like, I'll just use right and head. First, I just use right and head, right? Let's use right and head. So then instead of moving left, I'm moving head here. I'm moving like, head here, right? And so on and so forth. And I want to return the original linked list. If I do return head here, it will not return to me the original linked list. Why? Because I have moved it forward, right? The reference types, you have moved head forward. So if you return head is probably going to be like, the end or something. Does that make sense? So whenever you're solving a linked list question, and if you're returning the whole linked list or anything, what we do is that we store the head in a variable first. We store it, I usually call it like results or like head or like temp is equal to head or something. What I'm trying to say is this. If you'll be returning the linked list, starting from its head, the original thing, please always store that variable, that address in some variable before you use that pointer. The moment you use the pointer, it's going to move on ahead in your linked list. Does that what I'm saying makes sense? Like if you've seen this, if you saw the president, you probably come across this situation where you may end up moving some pointer forward. And then you're like, return head, you're like, no, head has already moved somewhere else. So like if you look at some of my questions, like if I solve these things, look, merge two sorted lists. Can you see what I'm doing here? Merge two sorted lists. I'm going to use ing, right? Instead of using list 1 and list 2. Because if I end up using list 1 and list 2, because the reference types, like they just mess up. They'll be like, list 1 and list 2 will probably be at the end of the list, but you want maybe the start. So please don't do that. What I'm saying may not make sense when you do the problems you understand. Okay, now let's come back to the question. Okay, so we already understand what the algorithm is. Choose the minimum, choose the minimum. Okay, now this code, look at this code, and let me know if this code makes sense to you. It's the same thing, right? I is list 1. So compare I, to J, like, please make sense. Tell me it makes sense to you. If I is the first pointer, basically. If the first pointer's value is less than the second one, we choose that one, right? Else we choose that for the second one, and then we move the result for it. Does this make sense to everyone? And then at the end, I'm like, maybe the first list was shorter, right? But here I'm like, while both of them has not ended, right? While both of them is not none. If the second one has ended, that means that the first guy is not done. So therefore, let's continue him, right? And then this one is like, if the first one is done, maybe the second one is not done, right? At least one of these would be true, At most one of these would be true. After that, we do this. Does the algorithm make sense to everyone? This code here. I just want to clean up this code. Does it make sense to everyone? This code.
Yeah.
Yes.
Right. Do you agree the code makes sense, right?
Yes.
Okay. Issue number 1. Now, please follow me carefully. Follow me so carefully. Let's clean up your code. This was my code. This was when I started. Okay. So we were merging the list, right? Can you see we are both here, right? P and Q. And let's assume that this guy was longer. Look at this. Situation number 1. Right? Let's assume they've all moved down and they both go to 4, right? And Q has got to also 4, right? And let's say, we chose that for this. So this guy has got to none. So we can see that Q list 2 has ended. Can we all see it? Can you see list 2 has ended? This is list 2. It has ended. So like the for loop will stop. Like the for loop will stop. Where is it good? Like the for loop will stop because for loop says while I is not none and J is not none. While both of them have not ended. Can we all see it here? So like the for loop will stop. Can we see it? Because Q is on none. Does everybody see this?
Yes.
Okay. But then P is not done. List 1 is not done. Can we all see it here? It's just here. Its elements here have not been, stored. Can we all see it here?
Yes.
Can everybody see this? List 2 has ended. List 1 has not ended. All right. Can we proceed?
You can.
It's coming a lot to be like, let's breathe for 30 seconds. Okay. Now let's move on. So number 2, you know that these are reference types, right? Like P is actually storing an address, right? P storing an address, right? And because P storing an address, look at, please follow me carefully. Because this guy has ended, so now my result looks something like, this is how the result looks like. 1, 2, 4, 1, 2, 3. The result looks something like this. 4, right? And look at something like, please follow me carefully. Look, the result variable 2 is standing here. The results pointer is standing here. Look, the results pointer is standing here. This is basically a results pointer, right? So if you look at the code, so we created a results node, right? And that is what you're going to use to create the new chain, right? The new linked list, right? So whichever you choose, you just set S next to this, right? So that's what result is. But you see, results, I just created a certain dummy node, right? So results started like as a dummy node, right? And then whichever you choose, you just set it to be the next of result, the next node of results. Does that make sense? How I created this one? So just created a certain variable. So this is what I did at the start. Let's create a certain node, right? Let's call it the results node 0. So if I compare 1 and 1, whichever I choose, so let's say I choose that for P, I just make that one the next for results, right? The next one I choose, I make it the next, and so on and so forth. Does that make sense to everyone? Does that make sense to everyone, please? What I got this. Okay.
Yes.
So now this is the current state. List 2 has ended. List 1 has not ended. That means result is not complete yet. So we have to complete results. Like results needs to have 5 and 6. Please, does anyone see the state? I want everyone to understand this current state. All right. Is everybody understand the current state? I beg. Before we proceed.
Yeah.
Yes.
Yeah.
Okay. Now let's see the next thing. Next thing then becomes, now we need to link results to the remaining of the linked lists, right? But if you look at my code, so that's we have to first of all link results to the rest of the remaining list. Now, what I'm doing now then is I'm like, hey, if the list 1 has not ended, loop through it and connect results. Like, so I loop through it, I'm like, connect it. I don't need to do that. I don't need to do this while loop. All I need to do is a simple if statement. Because this P guy, right, is pointing to a linked list. It's like the head of this P guy is something like this right now, right? So I can simply do result.next is equal to P, and that should work. I don't need to iterate through like everything. Does that make sense to everyone? Like I don't need to iterate through everything. That's what I want to show you here. That P is pointing to the address of a linked list starting at 4, right? It's pointing to some linked list. So I can simply do results.next is equal to P, and that will be same as copying this whole thing and bringing it here. Does this make sense?
Yes.
Please, does this make sense? Because look, because P is a linked list that starts as 4. It's a node, right? And you can use P to get the rest, right? So if I just do results.next is equal to P, it's just like I have brought, this chain, it's just like I brought this node 4 from P. And if you bring this node 4 from P, right, it's going to end up automatically bringing the rest. Because if you do that, next is to give you 5, next is to give you 6, right? So this code is not wrong, but you don't have to do this. I can just simply say if I, right, res.next is equal to I, and I should be done. Like it should be perfect code. It should work. Does that make sense?
Yes.
Okay, there are 3 things I want to show you on this code. So this is number 1. Don't give up yet. We're almost there. I'm showing these hard things so that you just know them. When just listen to me now. When you go to the problems and everything, the practice, they make more sense to you because you see them in action. Okay, let's go to number 2. So that's number 1. That if you're just going to link the linked list, you don't have to loop through, like you don't have to do P is equal to this and then P is equal to the, because basically just doing a duplicate work to be honest, just redundant, right? Case number 2. Can we see how we have moved? Results to travel through everything? At the end, results is somewhere here, right? So the question is, what do I return? You have moved result at the start when it's initialized, result was here. But now you have moved this result guide through the loop. That's the thing I was mentioning at first. Can you see we have been moving results equal result of next time? Can we also be moving results ahead in future? Can we all see it?
Yeah.
So that means that if I come and do return results, what will happen? I'm going to end up returning a linked list starting at whatever results was at when I ended the code. But that is wrong, right? Because we want to return the result of the new linked list, which you start from the starting here. Can we all see it?
Yeah.
Please, Derek,
Yeah.
does it make
Yeah.
Yes.
That is why when I first created results at the start here, I assigned another variable to it called temp because they'll point you to see their reference types, right? And that is why you have this line of code here. This line of code here. I created results, but I'm like, results, I'm going to move you forward. So let me store your current address in this guy temp. So this code I have here, it's basically because of this. Like, so that when I move results, so I can move results on results address will change. The address points to may change, but temp also stand at the same place. That's what I was mentioning at first. That if you move the pointer forward, right, at the end, it's going to be at some other place, right? But look, I stored the address. That was how we started, right? That was when we started. That was the same thing I showed when we started. Like, let's our reference types, right? So you may change this guy, you may move this guy forward and everything, but this guy remains as it is. Does that make sense to everyone? So at the end, what I want to return is actually temp.next because temp is just a dummy node you just use as a trick, right? But it's .next is a linked list starting at this first node 1. Does that make sense to everyone? That is why we have this. Sorry. That's why we have return temp.next. These things I just mentioned, I believe, are the most difficult parts of linked list. Once you understand them, linked list becomes so manageable for you. So please, if these things don't make sense, sit down and go through them. That's one last thing I want to show you. It's not related to linked list, related to genome programming, and it's going to make your life a wonder. Make your life amazing. Go make your code much better. You don't need to write all this code. And you write it in code, you'll be like, you're truly a tech elevate person. Okay. Can we go on to that? We want to breathe. We're almost done. This is the last thing. Shall we do it? Okay, look at this. It's beautiful code. It's amazing code. So usually you're looping through two things, right? You're looping through two things. You're like, one may be longer than the other, one may be shorter, like, and this is how we are solving ours. We're like, so it's even if you understand what I said, you understand this part to face the problem. They're like, I have to now come and look through these things. It's like, nah, man, it's a lot of work, right? So this is what you can do. In looping through it, instead of saying this condition is like, while both of them have not ended, change this and to all, which means that if one has not ended, this is like, if both of them have not ended, continue. This all means that, hey, even if the all means if this guy has ended, list 2, still continue the iteration. Does that make sense to everyone? All means like you need both of them to happen. You need both of them to end, right? So if I take a list, right? If I'm looping to a list, let me give you an easier case. Look, if I have two lists, list 1, like regular list, like list 1, list 2, list 3, list 4, right? Like, and list 2 is equal to like 5 and 6. I want to merge these ones. Can you see they have different length? Right? They are sort of different length. The code for this is simple. And it's like 2 pointers. Let's call it P1. Pointer 1 is going to be 0. Pointer 2 is going to be 0. So pointer 1 will go through list 1. Follow me carefully. Pointer 2 go through list 2, right? Then I'll be like, while P1 is less than length of L1, or P2 is less than length of L2. So that's like, so if I say and, that means that both of them must be less, right? But if I say or, that's like, hey, whether this guy or this guy, it's valid, let the loop continue. Does this make sense? The or case. Does the or condition make sense to everyone?
Yes.
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 The 40 of you, does it make sense? The or
Yeah.
case. So or is like, continue it. So far as some guy is valid, so far as some guy has not ended, please continue. But then somebody's like, but if I continue inside the loop, I'll be doing P1 plus equals 1 and P2 plus equals 1. Won't it lead to an error? Because look, because you know that if you try to access out of it, it's going to give you an error, right? We all know that, right? If it's in your, so then what you do is that it's a trick. Like, okay, P1. So let's say we do something like value 1 is equal to L1 of P1, less 1 of P1. And value 2 is equal to L2 of P2. Can we all see it here? I'm getting the value that P1 points to, and the value P2 points to. Do you understand this code? What I just did? Step by step. Do you understand this? Okay. But then you know that this thing can give you an error if P1 is out of bounds, right? If it's more than, the right answer, right? So it is. Okay, but you also know that what you do is that you compare, right? You also compare. If V1 is less than V2, that is when you choose the value that's when you choose, right? V1. I think they code in steps so it makes sense to you, right? Else, res dot append V2. Do you understand the code so far? So get the value that the 2 pointers point to, choose the minimum because if you still want our result. So the question is we want to merge this sorted list and return a sorted output, right? So if V1 is minimum, you choose that one, right? Else you choose V2. Does that make sense? Does the code so far make sense to everyone?
Yes, it does.
Okay, so now I come to simplify this code. This less than here, right? This less than here, right? Can anybody tell me what is the lowest or the mark? What's the biggest number possible? Biggest number possible. In Python is math dot infinity, right? It's positive infinity. It's infinity. That's the maximum. That's the biggest number possible. What is the lowest number possible? Negative infinity, right? Does everybody agree? So if I compare any number in the world to positive infinity, that number is smaller, right? We're going to use that one. So what I'm going to do is I'm going to be like, well, let's V1 be L1 index P1 if it is still inbound. If it has ended, make it the biggest number possible. Can we all see it? And the same thing here. So can you see what will happen? Oh, this one. Oh, so this is supposed to be P. Supposed to be P. Else, math dot infinity. So that means that if V2 has ended, V2 is going to be positive infinity. Do you agree? V2 will be positive infinity. Do you agree? If V2 has ended, V2 will be infinity. Does everybody agree? If V2 has ended, because V2 is a shorter list, so V2 will be infinity, positive infinity. Everybody agrees with me?
Yes.
Okay. So that means that, but V1 has not ended. So that means that whatever value V1 is, it will be less than positive infinity. So the loop will always enter here. The loop will always enter here. So the pointers can keep on misbehaving, doing anything they want. But because of this logic I have added here, the code will end when everybody has been processed to the end. So you don't need to finish this code and come and do while, P1 has not ended. No. This logic here handles everything for you. Assuming it was like, once it's sorted in descending order, like biggest first, just have to make this guy a negative infinity and this guy a negative infinity. And if I could like this in an interview, the guy is like, I needed you more than anybody needed me. Exactly. So amazing code. If you do other programming languages, they use ternary operator. Like V1 is equal to L1 index P1. They actually do this. L1 is less than length of P1. If this is the case, then if this is true, question mark, then P1 index L1. What am I doing? L1 index. I've messed up everything. I don't know, but I will get the idea, right? So we can use the same thing for linked list. The same operator for linked list. So when I go a bit older, so you can see this code is very ugly. When I go a bit older, let's see. I'm sure I would code that code. I'm sorry, this I didn't get older. Probably go older in 2023. Oh, this another beautiful code. This code is beautiful. Hey, can I show you this code before you go? Let me show you this one.
Yes, yes.
This code is beautiful. I've seen this code. Like this code is beautiful. Let me show you this. Let me show you this. Please look at me. Look here. Like, this code is so beautiful. I think I saw it somewhere, and I was like, "This is amazing." Please follow me carefully. Maybe you follow me, sir. Look, can you see Q is at none? Can everybody see it here? And P is on a node, right? Can we all see it here?
Yes.
This is a beautiful thing about
Yeah.
objects. This is a beautiful thing about objects. I can simply be like result.next is equal to, right? Before that, let me show you something. Let me show you something. Look here. We are almost there. Almost there. I have to show you this thing as I may not be able to sleep tonight. Like it's amazing. Look at this. Create a variable called n and be like n is equal to the empty list or 1. Print n. Anybody, last quiz. What do you think this would be? I'll save you. Can you see the one here? Because this is what Audi is doing here. Or check, are you truthy or falsy? Is empty list truthy or falsy?
Falsy.
Falsy.
Then come and check, are you truthy or falsy? So when this is faulty, it's just default to the second one, right? Oh, so when I write this, it's like this is falsy. So just take this guy, right? In the same way, if I write a certain node is equal to none or some valid linked list, right? Some valid linked list. If this is none, right, it will assign itself to this one, right? So that code we just looked at, I was like results.next is equal to pointer 1 or pointer 2. So if pointer 1 is true, right, that means that this guy is not none, right? If this guy is not none, that means that, this list 2 has ended, right? So then it will assign it to this one. But if this guy is the one who ended, then to assign itself to this one. Does that make sense?
Yeah.
Yeah.
That is
Beautiful.
it.
Beautiful.
It's so beautiful. And it's just one line of code, right? Like, so that is like if you use and, you're like, well, both of them has not ended. But at the end, you're like, maybe one has not ended. You just write this code here and it's beautiful. So if list 1 has ended, list 1 will be pointing to none, but list 2 will not be none, right? So it will be like resonance equals to list 2. If list 2 has ended and not list 1, this one will not be none, right? And to replace it, if both of them have ended, both of them will be none either ways. And it's so beautiful. Yeah, I thought this code somewhere I was like, man, I have to write this code too. But I want to show you the OR case. I didn't write the OR solution. Oh, I switched to recursion straight away. But yeah, I'm going to end here. But code is amazing. Spend time, write code. Please finish these questions. You have 1 day for the week to end. Finish these questions, the English questions. Take your time, grind them. Look, actually, let me show you what I did. What I did was I put like 3 days there. Then I grinded English. Only English questions I did. I did so much of them that my brain now begins to think linked list. Like you get used to them, right? That's why we do questions in a week. Like on that question, you're only facing this material, so your brain begins to adjust and get used to them, right? Hey, you get stuck. Ask us in the group, right? Be like, why is this condition L1 and L2? I feel like that's the trick about linked list. When to end the condition. Ask us in the group. We will help you, right? Like grind linked list like 3 days. Immerse yourself into it, right? But you're supposed to do that this week, though. Okay, let me show you the task for this week. Recorder you can keep it, you can stop it, up to you.